Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0989, indicates an issue with the transmission fluid pressure switch, E, which is associated with the sixth clutch of the automatic transmission in the Honda Odyssey models from 2011 to 2017. This code suggests that the circuit for this pressure switch has either a short circuit or the switch itself is stuck in the on position. The sixth clutch is responsible for engaging the sixth gear, and its proper operation is critical for efficient power transfer from the engine to the wheels. When this DTC is triggered, the transmission may default to operate in only the third or sixth gear as a protective failsafe measure. This failure is attributed strictly to electrical circuit issues rather than mechanical problems within the transmission. Prior to any troubleshooting, it's essential to gather freeze-frame data and conduct a review with the Honda Diagnostic System, HDS, for a thorough analysis. The components affected by DTC P0989 primarily include the transmission fluid pressure switch E, located in the transmission assembly, specifically related to the sixth clutch system. This switch monitors the hydraulic pressure in the transmission and communicates with the powertrain control module, PCM, to ensure smooth shifting between gears. The switch's role is critical. If it signals incorrectly, it can lead to erratic shifting behavior. The switch is usually found in the vicinity of the sixth clutch within the transmission, making it integral to the overall function of the automatic transmission system. Failure of this switch or issues in its circuit can trigger the fail-safe mode of the transmission, limiting gear selections. Therefore, it's important to thoroughly investigate the condition and function of both the switch and its wiring during troubleshooting. The possible causes for the DTC P0989 primarily revolve around electrical circuit issues. These issues may include damaged wiring, shorts to ground, or open circuits that can cause communication failures between the transmission fluid pressure switch E and the PCM. Another potential cause is the sixth pressure switch being permanently stuck in the on position, which can occur from contamination or internal defects in the switch itself. Additionally, poor connections at the PCM could lead to errors in signal transmission. Each of these causes requires careful examination to ascertain the root of the problem and correct it effectively. When troubleshooting, an understanding of the circuit pathways and the role of each component is vital for diagnosis and resolution. The symptoms associated with DTC P0989 can significantly affect vehicle performance. The most evident symptom is the limited gear selection, where the transmission will only engage in third or sixth gear. This failure mode is a protective measure known as failsafe to prevent further issues while driving. Drivers may also notice that the vehicle is not shifting smoothly or could experience harsh engagements between gears. Additionally, the presence of warning lights on the dash can indicate transmission malfunctions, prompting further investigation. Understanding these symptoms helps mechanics identify the issue early and prevents potential drivability concerns. It's crucial to diagnose and address these symptoms promptly to restore normal transmission function. The first step in troubleshooting DTC P0989 is to turn the ignition switch to the on position, known as on 2, without starting the engine. This action powers the vehicle's electrical systems and prepares them for diagnostic checks. Next, it's essential to clear the existing DTC using the Honda Diagnostic System, HDS. Using HDS, the technician can access the AT data list to check real-time data from the transmission. This approach enables the identification of the current state of the sixth pressure switch allowing the technician to determine if it is on or off. Documenting this data is crucial, as it provides a baseline for further analysis. Following this procedure ensures an accurate start to troubleshooting any wiring or component issues related to this DTC. In the second troubleshooting step for DTC P0989, the technician will check the sixth pressure switch signal using the Honda Diagnostic System, HDS, in the AT data list. This step is vital for verifying the operational status of the switch. If the sixth pressure switch is found to be on, further investigation is warranted to address the circuit issue or replace the switch. However, if it is off, the system may be functioning correctly at that moment, suggesting an intermittent failure or an issue that may not be present currently. It is essential to document this finding, as it informs the next steps in troubleshooting. The data gathered here helps in isolating the problem, allowing for more targeted diagnostic procedures. The third troubleshooting step involves turning the ignition switch to the lock position, 0, thereby ensuring electrical systems are powered down while performing physical connections. Next, the technician should disconnect the transmission fluid pressure switch, E, 6th clutch connector. This step is critical for isolating the switch from the electrical circuit for further testing. Once disconnected, the technician will prepare to check the sixth pressure switch signal again using the HDS when the ignition switch is turned back to the on position. This procedure ensures the test can accurately indicate whether the switch is functioning correctly without interference from other components within the circuit. It is a systematic approach to narrows down the root cause effectively. In this fourth troubleshooting step, the technician again checks the sixth pressure switch signal using the HDS data list after reconnecting the ignition to on and disconnecting the switch connector. This check is crucial because if the sixth pressure switch is off at this stage, it indicates that the switch itself is functioning correctly and that the circuit is free from faults that would cause erroneous signaling. If the switch is off, this means the problem could be elsewhere, and the technician can move forward with diagnosing potential wiring issues. If the switch is still found to be on, this indicates a malfunctioning pressure switch, warranting its replacement. Such clear delineation aids in effective resolution of the stated issue, ensuring proper functionality of the vehicle following repair. The fifth troubleshooting step is critical for delving deeper into potential circuit-related issues. First, turn the ignition switch to the lock position, 0, to ensure all systems are powered down before proceeding. Next, the technician will connect the SCS service check signal line and utilize the HDS to conduct checks on various system components. Following this, it is essential to disconnect the PCM, Powertrain Control Module, connector C, identified as 49P, which involves accessing the module situated in the vehicle's engine bay or passenger area, depending on the model. This step prepares the circuit for continued testing by removing the PCM's influence on the system, allowing for a clearer assessment of continuity in the wiring between the PCM and the switch. This methodical procedure allows for an effective narrowing down of the cause of the DTC as it relates to electrical components. The sixth step is focused on checking the continuity of the wiring between the PCM connector terminal C31 and the body ground. Continuity testing verifies that the circuit path is intact without breaks. Specifically, the technician will ensure there is a good connection between the mentioned terminal and the body ground, which serves as a reference point for the circuit. This entails using a multimeter to check for continuity, which confirms whether the electrical signal can flow freely through the circuit. If continuity is present, it suggests that the wiring between these points is intact, leading to a probable short to body ground issue elsewhere in the circuit. If there is no continuity, the PCM may be faulty and require replacement, indicating that the engine control center is unable to relay proper signals for the transmission's operation due to internal damage. Final repair verification is crucial to ensure that repairs have effectively resolved the issue indicated by DTC P0989. After replacing the faulty transmission fluid pressure switch E or repairing any wiring issues found during testing, a technician must conduct a thorough test drive. This process allows for confirmation that the transmission functions correctly and smoothly shifts through all gears. After the drive, the technician should clear the DTC and any freeze frame data collected earlier with the HDS to reset the transmission system for accurate monitoring. Following these steps will confirm that the vehicle operates within normal parameters without any remaining diagnostic codes. This final verification ensures that all aspects of the repair have been completed successfully, allowing for safe and efficient vehicle operation. Preventive maintenance is an essential aspect of vehicle ownership, particularly when managing potential issues like those indicated by DTC P0989. Regular inspections of the wiring associated with the transmission fluid pressure switch E can help detect fraying or damage before it escalates to a failure. Ensuring proper monitoring of the switch's performance during routine vehicle diagnostics with the HDS can catch irregularities early, allowing for timely interventions. It's also advisable to maintain proper transmission fluid levels and quality, as contaminated or low fluid can impact the system's performance. This proactive approach not only extends the lifespan of the components, but also ensures optimal vehicle performance. Regular maintenance schedules and awareness can significantly reduce the risk of future DTC occurrences, resulting in better reliability for your Honda Odyssey. In conclusion, understanding and addressing DTC P0989 is vital for maintaining the performance and safety of the Honda Odyssey from 2011 to 2017. Through the step-by-step troubleshooting guide, technicians can methodically pinpoint issues related to the transmission fluid pressure switch E and its associated circuitry. This structured approach not only resolves immediate mechanical concerns, but also fosters a deeper understanding of the vehicle's transmission system. The importance of preventative maintenance cannot be overstated, as it plays a key role in reducing the likelihood of recurrence of DTCs and ultimately ensuring a prolonged and reliable service life for the vehicle. By consistently monitoring and maintaining all electronic and mechanical components, vehicle owners can enjoy safe and trouble-free driving experiences. Thus, continuous education and adherence to service protocols are paramount in successful vehicle maintenance. Please like and subscribe to the channel. See you next time.